Hi children, our next topic is prime numbers and composite numbers. We already studied all numbers have two or more factors except one. For example, factors of 3, 1, 3 are the factors of 3, 4, 4. Factors of 4 are 1, 4 and 2. 5. 1, 5 are the factors of 5. 6. 1, 6, 3, 2 are the factors of 6. Here some numbers have only 2 factors. Here 3 and 5 have only 2 factors and some numbers have more than 2 factors. The numbers which have only 2 factors are called prime numbers. Here 3 has only 2 factors, 1 and 3. 1 and the number itself. Some numbers have only 2 factors, 1 and the number itself. Such kind of numbers are called prime numbers. Here 3 is a prime number. Prime number. And some numbers have more than 2 factors. Here 4 has 3 factors and 6 has 4 factors. Some numbers have more than 2 factors. Such numbers are called composite numbers. Composite numbers. Here 5 is a prime number and 6 is a composite number. Okay. Next, which are the factors of 1? 1 into 1 equals 1. 1 has only one factor, that is 1. So, 1 is neither prime nor composite. 1 is neither prime or composite. Clear? Next is prime factorization. What is factorization? We already studied that. Writing a number as the product of its factors are called factorization. If all the factors are prime numbers, then it is called prime factorization. Okay? Consider one example. 16. We can write 16 equals 2 into 8. Okay? This is the factorization of 16, but this is not a prime factorization. Here 8 is a composite number. So, we can split this 8. 2 into 4. Okay? Then 4 is a composite number. 4 we can split 2 into 2. Clear? Then 16 equals 2 into 2 into 2 into 2. Now all are prime numbers. This is the prime factorization of 16. Clear? Next, example 1. List the prime numbers between 20 and 30. First we can write all the numbers between 20 and 30. 21, 22, 23, 24, 25, 26, 27, 28, 29. Factors of 21, 1, 21, 7, 3, 22, 2, 122, 11, 2. 23, 1 comma 23. Is there any other factors for 23? No, only two factors. 24, 1, 24, 3 8s, 6, 4. Then 25, 125, 5, 5 fives are 25. Then 26, 126, 2 comma 30. 27, 127, 9 into 3, 9 comma 3. Then 28, 128, then 2 into 14, 29, 1 comma 29 only. Here, which are the prime numbers? Here only two prime numbers, 23 and 29. 23 has only two factors and 29 also has two factors. So, prime numbers are prime numbers. (23) and 29. Okay, next is example 2. Find the prime factorization of 24. We can write 24 like this. 24 is an even number. So it is divisible by 2. We can divide like this. Okay. In 2, how much 2's are there? Only 1, 2. Right here 1. Clear? Next, in 4, how many 2's are there? 2 2's are 4. Clear? Then 12. 12 is an even number. It is divisible by 2. Then how much 2's are there in 12? 6 2's are 12. 6 2's are 12. Then 6 is an even number. It is divisible by 2. How much 2's are there in 6? 3 2's are 6. 3. Next, 3 is an odd prime number. 3 is an odd number and also it is a prime number. It has only two factors, 1 and 3 only. So it is divisible by 3 only. So 3, how many times? 1. Clear? We can write the prime factorization of 24 equal to 2 into 2 into 2 into 3. This is the prime factorization of 24. Listen children, next is example 3. Here we are going to discuss about how do we find the HCF by using the method prime factorization. First we can find the prime factorization of 28 and 42. Here 28 is an even number. It is divisible by 2. We can divide it by 2. How many times 2's are there in 2? 1 time. In 8, 4 times. Again 14 is an even number. It is divisible by 2. In 14, 7 2's are 14. Then next is 7. 7 is an odd number and also it is a prime number. So it is divisible by 7 only. It is divisible by 7. How much time? 7 is there in 7? 1 time. Next is 42. 42 is an even number. It is divisible by 2. Then 4. How much times 2's are there in 4? 2 2's are 4. In 2, how much time 1? 1 2's are 2. Clear? Then 21. 21 is an odd number, but it is divisible by 3. How much time 3's are there in 21? 7 times 3's are there in 21. 7 3's are 21. 7 is divisible by 7 only. 1 time. Okay? We can write here 28 equals 2 into 2 into 7. And 42 equals 2 into 3 into 7. Okay? Here 2 is common factor and 7 also common factor. Okay? Then HCF equals 2 into, take 1 from this pair and 1 from this pair. 2 into 7. Clear? 2 into 7 is equals 14. 14 is the HCF. Next example 4. Find the HCF of 125 and 175 by prime factorization method. First we can find the prime factorization of 125 and 175. Here 125. 125 is an odd number. It ends with a 5. It is not divisible by 2. But it is divisible by 5. So we can divide it by 5. How much time 5's are there in 12? 2 times 5's are 10. 3 times 5's are 15. So 2 times 5's are there in 12. 2. Okay. But here carry over 2. So this become 25. Clear? In 25 how much 5's are there? 5 5's are 25. Clear? Here 25. 25 is an odd number. It is divisible by 5. How much times 5's are there in 25? 5 5's are 25. Again 5 is divisible by 5. Okay. Then 175. 175 is an odd number. But it is divisible by 5 because its units place digit is 5. So we can divide like this. In 17 how much 5's are there? 3 5's are 15. 4 5's are 20. So 3 times 5's are there. 3 5's are 15. Carry over 2. So this 5 become 25. In 25 how much 5's are there? 5 5's are 25. So this here we have 35. In 35 how much 5's are there? We can divide it by 5. 7 5's are 35. Here 7 is an odd prime number. It is divisible by 7 only. So we can divide it by 7 one time. Here 125 equals 5 into 5 into 5. 175 equals 5 into 5 into 7. Here this we can pair like this. From each pair take 1. So highest common factor HCF equals 5 into 5. This equals 25. Take one number from each pair. From this pair take 5 and this pair take 5. So 5 into 5 equals 25 is the HCF. Next, prime factorization and common division method of finding LCM, lowest common multiple. Next, we are going to discuss how do we find the lowest common multiple by using prime factorization method. That method is called a common division method of finding LCM. Here, we can find the prime factorization together. Listen carefully. To find the LCM by common division method, we are writing the numbers together. Here 12 is even number, 20 is even number and 30 is even number. So all numbers are divisible by 2. We can divide all number by 2. In 12 how much 2's are there? 6 2's are 12. In 20 how much 2's are there? 10 2's are 20. And in 30, 15 2's are there. Okay. Then divided by 6 is even number, 10 is even number, but 15 is odd number. So these two numbers are divisible by 2. We can divide these two numbers by 2. How much times 2's are there in 6? 3 times 2's are there in 6. In 10 how much time? 5 times 2's are there in 10. 15 we cannot divide by 2. So write down 15 like this. Okay. Then next 3 is a prime number. It is divisible by 3 only. 5 is a prime number. It is divisible by 5 only. But 15 is divisible by 3 and 5. So we can divide first all these numbers by 3. In 3 how much time 3's are there? 1 time. 5 is not divisible by 3. So write down 5 like this. How much time 3's are there in 15? 5 times 3's are there in 15. Okay. Then here 1, 5 and 5. 5 are divisible by 5. 1, 1, 1. Clear? Then LCM equals 2 into 3 into 5. Clear? Here is equals 5 into 2 10. 3 into 2 6. So 10 into 6 equal 60. 60 is the LCM. Next method is prime factorization method. Common division method we already discussed. Here we are going to discuss prime factorization method. 12 is an even number. It is divisible by 2. 6 2s are 12. 6 is even number, which is divisible by 2. Then 3 2s are 6. 3 1. Okay. Then 20. 2. 1 2s are 2. 10. 10 is divisible by 2. 5 2s are 10. 5 is odd prime number. 5 is divisible by 5 only. 1. Then 30. 30 is even number, divisible by 2. In 3, 1 time. In 10, 5 times. 5 is odd number, but it is divisible by 3. We can divide it by 3. How many times 5s are there in 15? 5 times 5, 1. Okay. Then 12 equals 2 into 2 into 3. Then 20 equals 2 into 2 into 5. Then 30 equals 2 into 3 into 5. Here, which are the factors? 2, 3 and 5. The most occurrence of 2 here 2 times, here 2 times, and here 1 time. So, we have to take the most occurrence. Here 2 times 2 are here and 2 times here. So, take 2 times 2. Then most occurrence of 3. Here 1, here 1. So, take 1 time 3. And 5 1 time. 5 2s are 10, 3 2s are 6. 10 into 6 equals 60 is the LCM. This way also we can find LCM. Next is example 2. Prime factorize 35 and 56. Hence find their LCM and HCM. 35. 35 is an odd number, but it is divisible by 5. 5. How much time 5s are there in 35? 7 times. 7 is a prime number. It is divisible by 7 only. Then 56. 56 is an even number. It is divisible by 2. In 5, how much time? 2 2s are 4. This becomes 16. In 16, how much time? 8 2s are 16. 28 is an even number, divisible by 2. 1 time, 4 times 2s are there. 14 is an even number, divisible by 2. 7 times 2s are there in 14. 7, 1. Okay. Then 35 equals 5 into 7. 56 equals 2 into 2 into 2 into 7. Here only one common factor, 7. So HCF equal to 7. LCM equal to here common factor 7, or most occurrence of 7 is equal 7 1 time. So 7 into 5 into how much time? 2 into 5 2s are 10. 7 2s are 14. Sorry. 5 2s are 10. 7 4s are 28. 28 into 10, 280. So 280 is the LCM and 7 is the HCF. Example 3. Find the LCM of 12 and 30 by common division method. We can do prime factorization together. That is common division method. 12, 30. Here both are even numbers, so we can divide both by 2. How much time 2's are there in 12? 6 times. In 3, 1 time, and in 10, 5. Then 6 is divisible by 2 and 15 is not divisible by 2. First we can divide 6 by 2. How much time 2's are there in 6? 3 times. 15 is not divisible by 2, so write down. 3 is divisible by 3 only and 15 is divisible by, also divisible by 3. In 3, 1 time 3's are there. In 15, 5 times 3's are there. 1, 5. Here 5 is divisible by 5 only. So 1, 1. LCM equals 2 into 2 into 3 into 5. Here 5 into 2 equals 10. 3 2's are 6. So 6 into 10 equals 60. 60 is the LCM. Find the LCM of 14, 35 and 105 by common division method. First we can write the prime factorization together. 14, 35, 105. Here 14 is even number. It is divisible by 2. 35 is not divisible by 2 and 105 is not divisible by 2. First we can divide 14 by 2. 14 is an even number. It is divisible by 2. So how much times 2's are there in 14? 7 times 2's are there in 14. 35 is not divisible by 2. 105 also not divisible by 2. Here next 7 is divisible by 7 only. 35 also divisible by 7 and 105 also divisible by 7. So we can divide all numbers by 7. How much times 7's are there in 7? 1. In 35, 5 times 7's are there. In 105, in 10, 1 7's are there. In 35, 5 times. Then 5 and 15 divisible by 5. 1 and 3. And 3 is divisible by 3 only. LCM is equals 2 into 7 into 5 into 3. Here 5 into 2 equals 10. 7 into 3 equals 21. So 21 into 10 equals 210.